Hey everyone, welcome back. Before we can effectively test AI system for vulnerabilities, we need to understand exactly how they work. And I mean really understand them, not just a buzzword. Today we are going to break down artificial intelligence and machine learning in a way that's actually useful. No fluff, no marketing speech. Just the technical foundation you need to be effective in AI security. So, we are covering what AI actually is versus what people think it is, how machine learning really works under the hood, why the knowledge is essential for finding vulnerabilities, the specific attack surface this creates. By the end of this chapter, you will understand AI system well enough to start thinking like an attacker. Let's dive in. Understanding AI versus machine learning. So, what exactly is artificial intelligence? Let's start with the basics. Artificial intelligence, despite what science fiction tells us, is simply the software that can perform tasks we typically associate with human thinking. Here is what AI can actually do today: recognize pattern in data better than humans, make prediction based on those patterns, process natural language and response appropriately, analyze image and identify objects, generate new content based on learned examples. Think of it this way: if you have ever used Netflix recommendation, Google Translation, or Siri, you have interacted with AI. Those systems are not conscious and truly intelligent. They are just really, really good at math. The key insight here is that AI does not think like a human. It uses statistical pattern in a massive data set to make prediction, and that's the difference is exactly what creates security vulnerabilities. Machine learning, the engine behind modern AI. Now, machine learning is the specific technique that power most of the AI you interacted with daily. Here is the fundamental difference. In traditional programming, we are using hard coded words like urgent or money in a programming to mark a specific email set as a spam. So that was used to happen. But now we have a machine learning and we are providing him approximately 100K emails and giving him a task that we have out of them there are like 50,000 spam and 50,000 are legitimate, and it need to be figured it out itself. So that's how it works. That's the magic. Instead of writing rules, the machine learn pattern from examples. This is incredibly powerful, but it also means that the system can learn anything we never intended. The relationship is simple: AI is goat, machine learning is the current taste model to achieve that goal. Deep learning is just a specific type of machine learning using neural network. Why this matter for security? Here is why this matter to us as a security professional. When a system learns from data instead of following explicit rules, it can be manipulated in a way traditional software cannot. If I want to break a traditional spam filter, I need to find edge cases in the rule. But with machine learning, I can potentially poison the learning process itself or craft input that exploit the statistical pattern the model learn. That's a completely different attack surface and it requires a completely different mindset. How machine learning actually works. Yep. All right, let's get into the mechanics. I'm going to walk you through the exactly how the machine learning system is built and trained. This is an academic. Understanding the process is essential for identifying where attack can occur. Every machine learning system goes through the same basic process. Think of it like building and training a new employee, but instead of teaching them with conversation, you are teaching them with data. Step 1: data collection, the foundation. Everything starts with the data, and machine learning is as good as the data it learns from. From our spam detection examples, where we had collected 100,000 emails, labeled them 50,000 as a spam and remaining 50,000 as a legitimate, Make sure the example represent the real world scenario. Here is the first attack vector. If attacker can influence your training data, they can influence what your model learn. We call it data poisoning, and we will cover it in detail later. Step 2, splitting the data. Honest training. That is crucial. You cannot test student using the same problem you taught them with. That's cheating. Same principle applies here. We need to train a model with the data that it has never seen it before. And what we are going to do, we are splitting the data as a standard formatting is like 80-20 or 70-30. So over here we are dividing it, reserving 80% for a training part and remaining 20 for the testing part. The test set give us honest assessment of how the model will perform in the real world. If you mess this up, you will think your model is amazing, but when it actually sucks. Step 3, training, where everything happens. This is where the magic happens, but it actually pretty straightforward. When you break it down, the training process, the model starts with random guesses. It look at the training example and make the prediction. It compare its prediction to the correct answer. It adjusts its internal parameter to get closer to the right answer. Repeat millions of times with different examples. Think of it like learning to shoot a basketball. You shoot, you see where you missed, and adjust your form and shoot again. Eventually, you get better with repetition. The key insight for security model is essential a mathematical function with millions of parameters that get adjusted during training. If we understand how these parameters work, we can potentially manipulate them. Step 4, evaluation, testing reality. After training, we test the model on data it has never seen before. This tells us how it will actually perform in the real world. The key metrics we are really looking at are accuracy, false positive, false negative, and edge case performance. From a security perspective, we are especially interested in those false positive and negative. They tell us where the model is weakest, and weak spot are exactly what attackers target. The security implication. Why machine learning create a new attack surface? Traditional software has a bug in code. Machine learning system has bug in learned behavior. That's the fundamental difference that create entirely new category of attack. When you write traditional code, you can trace exactly why it makes such a decision. With machine learning, the decision making process is based on the statistical pattern learned from the data, and those patterns might not be what you think they are. Example, a facial recognition system might learn to identify people based on the background and their photos rather than their actual faces. It works fine in a testing, but fails completely when deployed in a different environment. The three attack categories. One, training time attack. Attack the learning process itself. If I can sneak malicious example into your training data, I can teach your model to make mistakes I want. Imagine if someone added fake spam emails to your training data that set were designed to make the filter ignore certain attack patterns. The model learned that those patterns are normal. Interface time testing. Attack the train model by crafting input designed to fool it. Those look normal to human but cause AI to make confident wrong prediction. Think of it like optical illusion, but for AI system, I can modify a spam email in a way that are invisible to human but cause the filter to classify it as a legitimate. Okay. The model extraction and privacy attack. The attack model still its learn knowledge or extract information about training data. Even if I cannot directly access to your model, I might be able to query it enough times to reverse engineer it, how it works, or even figure it out what data it used to train it. Why this knowledge is matter for the AI red teamer. Understanding the fundamentals give you a massive advantage as a security professional. Most people treat AI system like a black box. They don't understand how they work or they cannot effectively trust them. But now you understand learning process, the data dependencies, and statistical nature of AI decision making. That means you can start thinking systematically about where vulnerability might exist.